Welcome to the lesson on Blueprint Reading Basics. Upon completion of this lesson, learners will be able to explain the importance of the skill of blueprint reading for a production technician. Learners will also be able to identify and differentiate between the various types of lines and symbols used in blueprints. Communication is a key tool for the development of any industry. The management communicates the policy and procedures to its employees. Customers communicate their requirements, and designers communicate to the manufacturing department. The technical language of communication between the designers and the manufacturers of the product is the blueprint. Blueprints contain all information that is required to produce the final product as designed. A blueprint is a technical drawing that uses a universal language to communicate information about a product to the craftsman, engineer, designer, and other members of the manufacturing team. Information about a part and its specifications are communicated by blueprints in such a way that those parts can be mass-produced anywhere in the world. The term blueprint originated when the prints had a blue background with white lines. Now, those prints are on a white background with black lines. However, they are still called blueprints. Some other common terms used by industry to refer to blueprints include technical drawings, engineering drawings, and manufacturing drawings. Blueprint reading refers to the act of interpreting the engineering drawing, which helps the designers and craftsmen get an idea of what the object will look like when it is completed. Industries across the globe prepare their blueprints by following the same universally adopted standards, symbols, and principles of engineering drawings. Blueprints are made on drawing sheets that are a standard size and shape. The standard size of these sheets is established by organizations like the American National Standards Institute, abbreviated as ANSI, the International Organization for Standardization, abbreviated as ISO, the American Institute for Architects, abbreviated as AIA, and the American Society for Mechanical Engineers, abbreviated as ASME. Some of the most commonly used standard blueprint sheet sizes can be seen in the table here. Now let us take a look at the various elements of drawings. All technical drawings will have some or all of the features that make a drawing interpretable by industry. These elements are lines, views, dimensions, processes, sections, and geometric positions. We will discuss these elements in detail in the upcoming slides. Lines provide graphic information about the external shape and details of an object. They are of varying shapes and thickness. Object lines are solid lines that form the shape and size of a part. Hidden lines are dotted lines that are not visible in a particular view. Center lines identify the center of the part that is symmetrical. The size of the part is labeled along with the dimension lines. A break line is a line that denotes that the information is the same throughout but is shown as shortened with a break. A cutting plane line indicates that the view of the diagram is the cross-section of the part at a certain angle. Views allow you to see the part from different perspectives and provide information on the internal and external features of a part. Normally, the basic views are projected from the top and side to get a two-dimensional image. Dimensions provide details of the size, position, and shape of features. They can also detail information on how to assemble parts. Baseline dimensions are those that provide basic measurements of a part. These include length, depth, width, breadth, thickness, and angle orientation. Processes provide information on how each part is produced and is represented by symbols and notes. Processes include casting, forging, bending, stamping, etc. Sections are the special views of an object that help us to understand the details of the internal construction of an object. Normally, the sectional view is obtained by cutting the part using an imaginary cutting plane. Lastly, geometric positions provide a relative position of each part with respect to one another. Blueprints are used across industries worldwide as an effective means of communicating product designs among various technical departments. They bridge the gap between designers who conceptualize ideas and manufacturers who bring them to life, especially when direct communication is not feasible. A well-crafted blueprint contains comprehensive information about the product, ensuring all specifications are clearly conveyed. These technical drawings facilitate idea sharing not only between different levels of an organization, but also with customers, allowing them to provide input on the design. By standardizing communication, blueprints reduce misunderstandings and errors in the production process. For example, when a design engineer shares a blueprint drawing of an automotive component with a supplier, it serves as a critical communication tool. The drawing provides exact specifications, ensuring the supplier can manufacture the part to meet the required standards. It clearly conveys the engineer's design intent, reducing the risk of misinterpretation and potential production errors. The use of standardized symbols and conventions in blueprints facilitates clear communication across different teams and organizations in the automotive supply chain, promoting consistency in the manufacturing process. In summary, a blueprint is a technical drawing that uses a universal language to communicate information about the product to the craftsman, engineer, designer, and other members of the product development team. Being able to read blueprints is an important skill for a production technician. This skill assists in communication between technicians and designers. Thank you.